The ecological footprint is a measure of human demand on the Earth's ecosystems. It is a standardized measure of demand for natural capital that may be contrasted with the planet's ecological capacity to regenerate. It represents the amount of biologically productive land and sea area necessary to supply the resources a human population consumes, and to assimilate associated waste. Using this assessment, it is possible to estimate how much of the Earth it would take to support humanity if everybody followed a given lifestyle. For 2007, humanity's total ecological footprint was estimated at 1.5 planet Earths. That is, humanity uses ecological services 1.5 times as quickly as Earth can renew them. Every year, this number is recalculated to incorporate the 3-year lag due to the time it takes for the UN to collect and publish statistics and relevant research. Although the term ecological footprint is widely used and well known, it goes beyond the metaphor. It represents an accounting system for biocapacity that tracks how much biocapacity there is, and how much biocapacity people use. Calculation methods have converged thanks to standards released in 2006 and updated in 2009. Overview: the first academic publication about the ecological footprint was by William Rees in 1992. The ecological footprint concept and calculation method was developed as the PhD dissertation of Mathis Wackenagel, under Rees' supervision at the University of British Columbia in Vancouver, Canada, from 1990–1994. Originally, Wackenagel and Rees called the concept appropriated carrying capacity. To make the idea more accessible, Rees came up with the term ecological footprint, inspired by a computer technician who praised his new computer's small footprint on the desk. In early 1996, Wackenagel and Rees published the book Our Ecological Footprint, Reducing Human Impact on the Earth with illustrations by Phil Testamail. Ecological footprint analysis compares human demands on nature with the biosphere's ability to regenerate resources and provide services. It does this by assessing the biologically productive land and marine area required to produce the resources a population consumes and absorb the corresponding waste, using prevailing technology. Footprint values at the end of a survey are categorized for carbon, food, housing, and goods and services, as well as the total footprint number of Earths needed to sustain the world's population at that level of consumption. This approach can also be applied to an activity such as the manufacturing of a product or driving of a car. This resource accounting is similar to life cycle analysis, wherein the consumption of energy, biomass, building material, water and other resources are converted into a normalized measure of land area called global hectares. Per capita ecological footprint, or ecological footprint analysis, is a means of comparing consumption and lifestyles, and checking this against nature's ability to provide for this consumption. The tool can inform policy by examining to what extent a nation uses more than is available within its territory, or to what extent the nation's lifestyle would be replicable worldwide. The footprint can also be a useful tool to educate people about carrying capacity and overconsumption, with the aim of altering personal behavior. Ecological footprints may be used to argue that many current lifestyles are not sustainable. Such a global comparison also clearly shows the inequalities of resource use on this planet at the beginning of the 21st century. In 2007, the average biologically productive area per person worldwide was approximately 1.8 global hectares per capita. The U.S. footprint per capita was 9.0 r, and that of Switzerland was 5.6 r, while China's was 1.8 r. The WWF claims that the human footprint has exceeded the biocapacity of the planet by 20%. Wackenagel and Rees originally estimated that the available biological capacity for the 6 billion people on Earth at that time was about 1.3 hectares per person, which is smaller than the 1.8 global hectares published for 2006, because the initial studies neither used global hectares nor included bioproductive marine areas. A number of NGOs offer ecological footprint calculators. Ecological footprint analysis is now widely used around the Earth as an indicator of environmental sustainability. It can be used to measure and manage the use of resources throughout the economy. It can be used to explore the sustainability of individual lifestyles, goods and services, organizations, industry sectors, neighborhoods, cities, regions and nations. Since 2006, a first set of ecological footprint standards exists that detail both communication and calculation procedures. Methodology. The ecological footprint accounting method at the national level is described in the EL Footprint Atlas 2010 or in greater detail in the calculation methodology for the national footprint accounts. The National Accounts Review Committee has also published a research agenda on how the method will be improved. There have been differences in the methodology used by various ecological footprint studies. Examples include how sea areas should be counted, how to account for fossil fuels, how to account for nuclear power, which data sources used, when average global numbers or local numbers should be used when looking at a specific area, how space for biodiversity should be included, and how imports-exports should be accounted for. However, as new footprint standards emerge, the calculation methodologies are converging. In 2003, Jason Venito-Ulis, Karl Maz, Christopher Gaudet, Dalia Shazan, and John Talbot developed Footprint 2, which offers a series of theoretical and methodological improvements to the standard footprint approach. The four primary improvements were that they included the entire surface of the Earth in biocapacity estimates, allocated space for other species, updated the basis of equivalence factors from agricultural land to net primary productivity, and refined the carbon component of the footprint based on the latest global carbon models. Studies in the United Kingdom. The UK's average ecological footprint is 5.45 global hectares per capita with variations between regions ranging from 4.80 R to 5.56 R. Two recent studies have examined relatively low-impact small communities. BedZ, a 96-home mixed-income housing development in South London, was designed by Bill Dunster Architects and Sustainability Consultants Bioregional for the Peabody Trust. Despite being populated by relatively mainstream home buyers, BedZ was found to have a footprint of 3.20 due to on-site renewable energy production, energy-efficient architecture, and an extensive green lifestyles program that included on-site London's first car-sharing club. The report did not measure the added footprint of the 15,000 visitors who have toured BedZ since its completion in 2002. Findhorn Eco-Village, a rural intentional community in Murray, Scotland, had a total footprint of 2.56 R, including both the many guests and visitors who travel to the community to undertake residential courses there and the nearby campus of Cluny Hill College. However, the residents alone have a footprint of 2.71 R, a little over half the UK national average and one of the lowest ecological footprints of any community measured so far in the industrialised world. Kevrel Farm, an organic farming community in Cornwall, was found to have a footprint of 2.4 R, though with substantial differences in footprints among community members. Discussion. Early criticism was published by Van den Berg and Verbruggen in 1999. Another criticism was published in 2008. A more complete review commissioned by the Directorate General for the Environment and published in June 2008 provides the most updated independent assessment of the method. A number of countries have engaged in research collaborations to test the validity of the method. This includes Switzerland, Germany, United Arab Emirates, and Belgium. Grazie al have performed a systematic comparison of the ecological footprint method with spatial welfare analysis that includes environmental externalities, agglomeration effects and trade advantages. They find that the two methods can lead to very distinct, and even opposite, rankings of different spatial patterns of economic activity. However, this should not be surprising, since the two methods address different research questions. Calculating the ecological footprint for densely populated areas, such as a city or small country with a comparatively large population for example New York and Singapore respectively may lead to the perception of these populations as parasitic. This is because these communities have little intrinsic biocapacity, and instead must rely upon large hinterlands. Critics argue that this is a dubious characterization since mechanized rural farmers in developed nations may easily consume more resources than urban inhabitants, due to transportation requirements and the unavailability of economies of scale. Furthermore, Such moral conclusions seem to be an argument for autarky. Some even take this train of thought a step further, claiming that the footprint denies the benefits of trade. Therefore, the critics argue that the footprint can only be applied globally. The method seems to reward the replacement of original ecosystems with high-productivity agricultural monocultures by assigning a higher biocapacity to such regions. For example, replacing ancient woodlands or tropical forests with monoculture forests or plantations may improve the ecological footprint. Similarly, if organic farming yields were lower than those of conventional methods, this could result in the farmer being penalized with a larger ecological footprint. Of course, this insight, while valid, stems from the idea of using the footprint as one's only metric. If the use of ecological footprints are complemented with other indicators, such as one for biodiversity, the problem could maybe be solved. Indeed, WWF's Living Planet report complements the biennial footprint calculations with the Living Planet Index of Biodiversity. Manfred Lenzen and Shauna Murray have created a modified ecological footprint that takes biodiversity into account for use in Australia. Although the ecological footprint model prior to 2008 treated nuclear power in the same manner as coal power, the actual real-world effects of the two are radically different. A life cycle analysis centered on the Swedish Forsmark nuclear power plant estimated carbon dioxide emissions at 3.10 grams per kilowatt-hour and 5.05 grams per kilowatt-hour in 2002 for the Tornäs nuclear power station. This compares to 11 grams per kilowatt-hour for hydroelectric power, 950 grams per kilowatt-hour for installed coal, 900 grams per kilowatt-hour for oil and 600 grams per kilowatt-hour for natural gas generation in the United States in 1999. Figures released by Mark Hartsgaard, however, show that because of the delays in building nuclear plants and the costs involved, investments in energy efficiency and renewable energies have 7 times the return on investment of investments in nuclear energy. The Swedish utility Vattenfall did a study of full life cycle emissions of nuclear, hydro, coal, gas, solar cell, peat and wind which the utility uses to produce electricity. The net result of the study was that nuclear power produced 3.3 grams of carbon dioxide per kWh of produced power. This compares to 400 for natural gas and 700 for coal. The study also concluded that nuclear power produced the smallest amount of CO2 of any of their electricity sources. Claims exist that the problems of nuclear waste do not come anywhere close to approaching the problems of fossil fuel waste. A 2004 article from the BBC states, the World Health Organization says 3 million people are killed worldwide by outdoor air pollution annually from vehicles and industrial emissions, and 1.6 million indoors through using solid fuel. In the US alone, fossil fuel waste kills 20,000 people each year. A coal power plant releases 100 times as much radiation as a nuclear power plant of the same wattage. It is estimated that during 1982, U.S. coal burning released 155 times as much radioactivity into the atmosphere as the 3 Mile Island incident. In addition, fossil fuel waste causes global warming, which leads to increased deaths from hurricanes, flooding, and other weather events. The World Nuclear Association provides a comparison of deaths due to accidents among different forms of energy production. In their comparison, deaths per TWh of electricity produced from 1970 to 1992 are quoted as 885 for hydropower, 342 for coal, 85 for natural gas, and 8 for nuclear. Footprint by country. The world average ecological footprint in 2007 was 2.7 global hectares per person. The average per country ranges from over 10 to under 1 hectares per person. There is also a high variation within countries, based on individual lifestyle and economic situation. The GHG footprint differs from the ecological footprint in that the former is expressed in units of GHG warming potential and is generated by products or services, whereas the latter is expressed in units of land area and is generated by whole societies. Implications. The average world citizen has an eco-footprint of about 2.7 global average hectares while there are only 2.1 global hectare of bioproductive land and water per capita on Earth. This means that humanity has already overshot global biocapacity by 30% and now lives unsustainably by depleting stocks of natural capital. See also. References. Further reading, Rees, W. Ecological Footprints and Appropriated Carrying Capacity, What Urban Economics Leaves Out. Environment and Urbanization 4, 121 doi, 10.1177/095624789200400212 Rees, W. E. and M. Wackernagle Ecological Footprints and Appropriated Carrying Capacity, Measuring the Natural Capital Requirements of the Human Economy, in Janssen, AAL Investing in Natural Capital, The Ecological Economics Approach to Sustainability. Washington, D.C. Island Press. ISBN 1-55963-316-6, Wackernagle, M. Ecological Footprint and Appropriated Carrying Capacity, A Tool for Planning Toward Sustainability. Vancouver, Canada, School of Community and Regional Planning. The University of British Columbia. OCLCA 41,839,429 or, Wackernagle, M. and W. Rees 1996. Our Ecological Footprint, Reducing Human Impact on the Earth. Gabrila Island, BC, New Society Publishers. ISBN 0-86571-312-X. Wackernagle, M. Schultz, N.B. Doomling, D. Linares, A.C. Jenkins, M. Capos, B. Monfrida, C. Lowe, J.A.L. Tracking the Ecological Overshoot of the Human Economy. Proc. Natal. Accord. Sci. USA 99, 9266 €71 doi, 10.1073/FNAS 142,033,699. PMCA 123,129. PMIDA 12,089,326 WWF, Global Footprint Network, Zoological Society of London Living Planet Report 2006. WWF Gland, Switzerland. Lenzen, M. and Murray, Essay 2003. The Ecological Footprint Euro Issues and Trends. ISA Research Paper 01-03, Chambers, N., Simmons, C. and Wackernagle, M., Sharing Nature's Interest, Ecological Footprints as an Indicator of Sustainability. Earthscan, London ISBN 1-85383-739-3, Rordsep P. C., Peterson G. D., Tenga Paragraph M., Bennett M., Holland T., Bensire K., MacDonald G. M., Pfeiffer L. Untangling the Environmentalist's Paradox, Why is Human Well-Being Increasing as Ecosystem Services Degrade? Bioscience 60, 576 €589 doi, 10.1525/bio. 2010.60.8.4 JCJM van den Berg and H. Verbruggen. Spatial Sustainability, Trade and Indicators, an Evaluation of the Euro Ecological Footprint Euro Unregistered Trademark. Ecological Economics 29, 63 €74 doi, 10.1016/s 0921-8009, 99, 00032-4 F. Gracie, JCJM van den Berg and P. Rietveld. Welfare Economics versus Ecological Footprint, Modeling Agglomeration, Externalities and Trade. Environmental and Resource Economics 38, 135 €153 doi, 10.1007/s 1064/006-9067-2 Ull, B., Wolf, S., and Anderson, W. A Modest Proposal, Global Rationalization of Ecological Footprint to Eliminate Ecological Debt. Sustainability, Science, Practice, and Policy 4, 5 €16. External links, Global Footprint Network Ecological Footprinter Overview, WWF Living Planet Report, a biannual calculation of national and global footprints, Life Cycle Assessment, Introduction, U.S. Environmental Footprint Fact Sheet, Interview with Bill Rees.